So, good afternoon, everyone. So, before I introduce myself, I'd like to thank the organizing committee for this amazing opportunity to come here and present in this prestigious conference. It's the first time, so I've enjoyed this a lot. So, as mentioned, my name is Bengie Ortiz. I'm here to present my teamwork is AI ML ready mHealth and Wearable data for Dyadic blood and marrow transplant, PMT by its abbreviation. So I'm currently a postdoctoral researcher, and the work that I'm presenting here, is currently supported by NIH K24 supplemental grant. So the outline of today's talk, I will provide an overview of our current project and its research aims. Then I will describe our current approach that we have developed in our lab at Michigan Medicine, followed by the results. And just based on the current results, we have figured out what are the most key challenges and barriers, and future directions will also be provided based on those. So if you take a look at this slide, the first point, you take a roadmap mHealth. mHealth is a mobile health, obviously, but what roadmap is. So I will explain you. That's a multi-component app that was developed in our lab, that shows is showing here on the left side, that shows the patient's activity and sleep and mood. Those are a multi-component app that are compatible with iOS and Android. There are multiple software developers that are behind the design of this product, and there are multiple versions that is constantly evolving, and it's being improving the shape, how the data storage, how data is processed, and those are positive activity features. And usually, the steps, sleep, and the heart rate are provided by the Fitbit devices, which are wearable sensors that are coming from the manufacturer. But there is another measurement that is provided by our software app in a 24-hour interval. It's a self-reported mood. And all of this was tested in a randomized controlled trial, which is the number is provided there. So we are currently working on the following aims for this grant: to develop high quality mHealth data set for AI ML applications in BMT research. And the aim number 2, to share the processed data and develop methods for AI ML community and mHealth research community also. So there are many, this is a multidisciplinary aim that will benefit people in the whole healthcare engineering area. And the thing is that the main heart and the most important task of this project is the overall pre-processing pipeline. So this is our overall pre-processing pipeline, in which our team have developed, and currently it is still under review at JMIR, mHealth and mHealth, and it includes several steps. Data extraction by storing acquired data in a Oracle database. Data standardization, which includes data duplicate removal and compliance algorithms. Data cleaning involving data smoothing and outliers removal. Feature extraction given by statistical summary metrics, visualization, and window-based feature extraction. And finally, the data integration stage, which is the stage that the whole pre-processing steps are taken into account to make the data AI ML ready. And eventually, we want to ensure that we follow an ethical development of the AI ML ready before making that publicly available. For data extraction, this is just to give you an idea how the data storage from. We were able to recruit 176 caregivers and patients at Michigan Medicine for over 3 years. And mood is provided by self-reported every 24 hours in the Oracle database in a table in the left that includes the participant ID, sleep count, and step count. The other 3 parameters that are next to them are provided by Fitbit wearables And note that the time resolutions differs. They have different sampling rates, and because of it, the start time, end time, and different time is also provided. Subjects are distinguishable by participant ID for mood and sleep. But for heart rate and steps, device ID is their identifier. In our preliminary pre-processing, our main goal is, okay, we are obtaining this, we are taking different parameters, different sampling rates, but eventually we want to combine them with the demographical factors from the patients which are collected in the different surveys in different time points, and we want to combine them. So in our latest download, we were able to obtain this amount of observations. For mood, approximately 380,000. For sleep, 3 millions, heart rate, 86 millions, and for step, 417 millions. So this is some of the results. For this slide, this is in one patient caregiver diet. We have a density plot on the left, which represents step counts, and we are looking for patterns in their data. But the one in the left shows a great deal of overlap. On the right, you can see the proportion of steps over time in 3 different types of steps. Sedentary is the dominant one. After that, for sleep, these plots give an example of our entire population and how the sleep patterns in different minutes, because the x-axis is in minutes, is providing different patterns to caregivers and patients. And this is for the whole 166 caregivers and 166 patients recruited. And in the right one, where you can see how the mood differs, and we were surprised how patients were reporting higher mood scores. We are currently in the process of cleaning duplicate entries and understanding the causes of it. We have also developed algorithms to filter the data based on data validity and subject compliance. We are applying the compliance filtering techniques to an average daily steps and daily heart rate counts. We are also in the process of quantifying the patterns of missing next in the data to remove all of the outliers, and feature extraction is also still in progress. So just to give you an idea, from one available paper that we were able to design a compliance filtering for heart rates and steps data, which reported higher duplicates. This is just to give a history for all participants based on the frequency. In the right, you can see that after applying a compliance filter of a minimum wear of 432 minutes or 30% of the day, we were able to obtain 83% of those observations. We have identified some key challenges and barriers. So this is a high-dimensional data. We are dealing with the dyadic longitudinal time series data in a vulnerable population that have, immunocompromised individuals that are going through cancer therapy. So this is a huge challenge, but this is a data that can be irregular and sparse, and compliance issues requiring also filtering and cleaning. And we want to improve the data quality. So wearable data for high dimension requires significant effort to pre-process and enrich the data quality. We are currently in the process of creating standardized method to pre-process data and integrate those data for subsequent data analysis. In the future, we hope to use the physiological data from wearables and apply AI ML strategies to better understand the mental health behaviors. In other words, develop digital behavioral biomarkers. Finally, and importantly, to fulfill the aim 2 of this grant, we want to make them publicly available at University of Michigan's Data Blue repository after taking the ethical development into account. I would like to acknowledge the whole team. This is what everybody that is collaborating in our hospital, the pediatric hospital, specifically to our main PI, Dr. Song Choi. And all the authors are involved, but it is important also to recognize the fund that support all of this work, the NHLBI K24 grant. That's everything. Yeah.
Yes.
So yeah, I'll try to do my best.
Thank you. Thanks for this talk. That was very insightful. I am wondering where you had your slide on data extraction. I'm wondering if you are, it looked like a little bit of a model, and I'm wondering if you're leveraging semantics in order to organize these data, or if you can give us a little insight on your process of harmonization.
Well, usually, we provide the wearables and everything is stored in the Oracle databases. So there are specific database, and everything is provided by roadmap and stored in the software app. And there's a direct technical connection with the database, and it keeps updating. Keeps updating, and even patients that have been reported, even though we have some survey data time points, they keep sometimes reporting the metrics, and eventually, there are technical differences how you can identify from a specific individual, a specific factor, or in what time resolution, because initially we have software developers that, they keep on improving the roadmap product, and instead, let's say, 5-second window, but eventually they make a minute level data. And depending on what the sampling rate is, we take everything into account just to improve the data quality. This is the heart of this, or the main objective of this grant.
Thank you. I understand that. And then my very quick question was, why leave the ethical part for the end? Did you have some considerations on or on establishing the process with some ethical considerations for the capture of the data, or what was the rationale for putting it at the end?
Well, this is the final steps, because usually, there are PHIs of, patient health informatics involved in this case. And since we are improving the data quality, but the thing is that we are considering that at the end, because at the end is that the aim is to make it public, and we don't want to share any confidential information. And we consider that this does the perfect fit for that to apply the ethical development after improving the data quality. Okay, that is, the data is identifiable. There's nothing involved. Okay, now we can proceed.
Thank you